84% of organizations right now are staring down this massive financial black hole, and it's basically disguised as their cloud strategy.
Yeah, that Flexor report was pretty eye-opening.
Exactly. According to the 2025 State of the Cloud report, managing cloud spend is now the absolute top-tier crisis for enterprise tech leaders. So, welcome to Kanerika's podcast, The Digital Shift.
Glad to be here for this one.
Today, we are taking a really deep dive into the material to decode exactly what happens when two enterprise titans collide. I'm talking about Snowflake and a Microsoft Fabric.
Right, and with their interoperability becoming generally available in early 2026, the timing on this is critical.
It really is, because the architecture you choose today to connect them, it's going to permanently dictate your long-term costs, your data governance, and honestly, the everyday dynamics of your engineering teams. Okay, so let's unpack this, because this is far more than like a theoretical whiteboard exercise about moving ones and zeros. It's a crucial business decision that dictates whether you're building a highly efficient data engine or an unmanageable financial drain.
I think looking at this purely as a technology integration is well, it's the first major trap organizations fall into.
Oh, really? How so?
Because it is fundamentally an organizational integration.
Yeah.
Before evaluating how to connect these two massive platforms, we really have to examine why an enterprise takes on the immense complexity of running both concurrently.
That makes sense.
Yeah, I mean, you do not absorb the licensing and operational overhead of two dominant data platforms unless they are solving completely separate, specialized problems for different factions within your company.
Right, we have to establish that divide.
Right.
Because the current enterprise reality essentially splits your talent into two distinct camps. On one side, you have Team A, which is your data engineers.
And they practically live in Snowflake.
Exactly. That is their native habitat. They rely on it for, warehouse-grade transformations, intense SQL performance, and the flexibility to just operate across multiple clouds seamlessly.
Right.
Then on the other side of the organization, you have Team B. And these are your data analysts, data scientists, and business intelligence users. And they live inside Microsoft Fabric.
Because they require that native, frictionless access to AI tools, right?
Yeah.
Like Azure OpenAI, predictive notebooks.
Yeah, and most visibly, they're the ones building out the executive dashboards in Power BI.
So you got these two teams operating with entirely contradictory optimization goals.
Right.
Team A prioritizes system stability, massive ingestion speed, and making sure automated pipelines do not break during the night. They want structure. They want rigor.
While Team B, they prioritize data freshness, instantaneous report rendering speed, and self-service analytics.
Exactly. They want agility and immediate access to the latest numbers. They just operate on entirely different frequencies.
It is exactly like having two brilliant, highly specialized teams working in completely separate, fortified buildings.
That's a great way to put it.
Like, Team A is in the manufacturing plant, refining these raw, high-grade materials. And Team B is in the design studio, needing those exact refined materials to build the final consumer product.
And the business executives looking at the final product, they don't care about the logistics of how the materials get from the plant to the studio.
Oh, not at all. They just want instant, direct lake speed reporting.
Right.
They certainly do not want to wait for a metaphorical truck to, manually ferry a batch load of data across town once a day. They need a secure, lightning-fast, continuous bridge between these two buildings.
If we connect this to the bigger picture, constructing a successful architecture here is not just about laying down the steel for that bridge. It's about establishing the true system of record without creating an operational bottleneck.
Okay, so who actually owns the data at what specific stage of its life cycle?
Exactly. If the bridge you build requires both Team A and Team B to stop their native workflows and coordinate a handoff every single time a piece of data moves, you haven't actually built a bridge.
What have you built, though?
You've built a toll booth.
Yeah.
You have engineered this systemic dependency that inevitably slows both teams down and frustrates business leadership.
Wow. Yeah, and the pressure to avoid that toll booth is exactly what drives organizations toward the first and currently most prominent integration method detailed in the content, which is fabric mirroring.
Right, fabric mirroring.
The entire goal here is to establish a seamless, continuous connection. Let's really break down the mechanics of this, because from my reading, this relies heavily on change data capture, or CDC.
That's the engine behind it, yeah.
Right. So instead of doing a heavy brute force copy of the entire database every single night, the system is essentially listening to Snowflake's transaction logs. It identifies only the net new activity.
Every individual insert, update, or delete.
Exactly, and syncs just those specific row-level changes over to Fabric.
It acts as an incredibly lightweight, continuous pulse. As Snowflake processes new information, the CDC mechanism captures those micro changes and lands them directly into Microsoft's storage layer, which is OneLake.
And it changes the format, right?
Crucially, yes, it lands that data in the open Delta Parquet format.
Yeah.
Delta Parquet is highly compressed and optimized for analytical reading.
So the immediate benefit that stands out here is the clean operational boundary it creates. Snowflake remains completely isolated and untouched.
Yes.
Team A does not have to alter their pipelines, their proprietary storage structures, or their compute optimizations to accommodate the analysts.
Meanwhile, over in Fabric, Team B gets instant T-SQL access to that exact data.
Right.
And because the data is already sitting in OneLake in that native Delta Parquet format, they unlock Power BI Direct Lake mode.
Which means there is no manual import cycle.
None. The dashboards render at blinding speeds because the reporting engine reads the files directly from the lake.
Okay, and the financial structuring for Microsoft makes this even more compelling. The storage footprint utilized by this mirroring process is totally free up to the limit of your Fabric capacity tier.
Yeah, that's a huge selling point.
For context, if an organization purchases the x64 capacity tier, they are granted 64 terabytes of mirrored storage without incurring a single extra cent for that specific storage space.
And the only compute cost generated on the Snowflake side is the incredibly minimal overhead of the CDC read operations scanning the logs.
Okay, wait, here's where it gets really interesting and where I actually have to push back a little.
Oh, okay, let's hear it.
We started this deep dive acknowledging that 84% of IT leaders are in a state of panic over their cloud spend. Isn't duplicating enterprise data exactly the kind of bloated, redundant practice that drives up those bills?
That is the natural assumption, yes.
Like, why on earth would an architect deliberately choose to make a second physical copy of petabytes of data when IT budgets are under such severe scrutiny? It sounds completely counterintuitive to everything we're taught about cloud efficiency.
I get that. It is the most common and valid challenge raised by CTOs when reviewing this architecture. The instinct is to view data duplication as a financial failure.
Right.
But you have to shift the perspective and evaluate what that deliberate duplication is actually purchasing for the organization.
What is it purchasing?
It's buying total operational independence. Because there are two distinct physical copies, each specialized team controls their own release cycles and computing environments.
Oh, I see. So if Team A decides to restructure a massive table or execute a complex schema change over in Snowflake, the CDC mechanism just automatically reads those changes and propagates them over to the OneLake copy.
Exactly. They don't have to schedule a cross-departmental meeting with Team B to coordinate a massive downtime window.
Because that operational friction is the hidden cost of cloud computing.
100%. Human capital, endless coordination meetings, and stalled engineering productivity are vastly more expensive to an enterprise than the fractional cost of storing compressed Delta Parquet files.
That makes a lot of sense.
Furthermore, this specific replication architecture is fully managed and self-healing. If a network connection temporarily drops or a service reboots, the CDC process remembers exactly where it left off and catches up automatically.
So you aren't paying a team of highly compensated data engineers to manually monitor batch jobs or restart failed data pipelines at 2 in the morning.
Nope. The platform boundary remains impeccably clean.
Putting it that way clarifies the value proposition immensely. You are essentially paying a slight predictable premium in storage infrastructure to insure yourself against the massive, unpredictable premium of human operational delay.
That is the perfect summary.
But giving everyone their own isolated sandbox gets incredibly expensive if your data scales to massive extremes. And that anxiety over redundant storage pushes companies to chase the absolute holy grail of data architecture, which is zero data movement.
All right, the elusive zero data movement.
And that brings us to the second approach detailed in our sources, which is the Iceberg external tables shared architecture.
Zero data movement is a very compelling philosophy. The concept is that data should be written once and queried infinitely by any platform without ever physically moving.
Which sounds ideal.
It does.
Yeah.
And with Apache Iceberg, which is an open source table format, this is technically achievable.
Okay, so how does it work?
Under this model, an organization converts its native Snowflake tables into the Iceberg format. Snowflake's compute engine then writes those Iceberg formatted files alongside a highly detailed metadata manifest into an external volume.
And this volume is typically what? A shared neutral cloud storage environment, like an Azure Data Lake Storage Gen 2 container.
Exactly, ADLS Gen 2.
So it's essentially pushing the data out of Snowflake's proprietary vault and into neutral international waters.
Right.
Then Microsoft Fabric comes along and simply creates what they call the OneLake shortcut. That shortcut acts as a direct pointer to that exact same ADLS container.
Yes, and Fabric's compute engines read the Iceberg files right where they sit. There is no CDC tracking logs. There is no automated replication.
Both enterprise platforms are reading from one single physical manifestation of the data.
And the underlying logic is undeniably attractive on paper. You eliminate all cross-platform network egress costs because the data never travels between platforms. Your total storage footprint is literally cut in half.
But, and I hear a but coming.
But this raises an important question that architects often overlook until it's too late. What actually happens to team velocity when two completely distinct organizational entities are forced to manage and rely on a single, highly sensitive physical asset?
I imagine it's a lot like forcing two roommates to share a single joint bank account.
That is a highly accurate comparison.
Right. Instead of transferring money from Team A's individual account to Team B's individual account and paying a small wire fee for the transfer, both teams just get a debit card that swipes from the exact same pool of funds in the middle.
Which saves on transfer fees.
But things get incredibly complicated if they aren't communicating perfectly about every single transaction.
Yes. By eliminating the financial cost of duplicating data, you introduce massive, rigid operational coupling. Let's examine the security implications.
Okay.
Both the Snowflake service principal and the Fabric OneLake shortcut require flawless, coordinated role-based access control, or RBAC, configured on that shared ADLS container.
An RBAC is not just a simple toggle switch.
No, it's an intricate web of security permissions.
Yeah.
A single, minor misconfiguration by either team blocks access for both platforms simultaneously.
Oh, wow. So if an engineer on Team A tightens a security policy on that shared storage container to comply with the new internal audit, Team B's executive Power BI dashboards could suddenly go completely dark.
Exactly.
And Team B wouldn't even have the visibility to know why it happened.
And the dependencies go much deeper than just security access. The mechanics of Iceberg rely heavily on its metadata manifest to tell query engines where the data actually lives.
Because Snowflake is the system originally writing the data, Fabric relies entirely on Snowflake to keep that metadata updated.
Right, that makes sense.
To do this, Snowflake has to execute an alter Iceberg table refresh command on a rigid, scheduled task. If that specific Snowflake metadata refresh task fails, times out, or simply misses its scheduled window, the Fabric users are instantly querying stale, outdated data.
And because Fabric doesn't control the refresh, it has no native way of knowing the data is stale.
None.
The dashboards will still load, but the executives will be looking at yesterday's revenue numbers thinking they are live. You would have to build entirely custom third-party monitoring pipelines just to ensure the two platforms are actually synchronized.
It introduces significant fragility.
That sounds incredibly fragile compared to the automated, self-healing nature of the Fabric mirroring approach.
It is. And beyond the operational risk, there is a severe performance penalty.
Apache Iceberg is a phenomenal open standard, but it is fundamentally not native to Snowflake's deeply proprietary internal engine. Snowflake owes its reputation for blinding speed to features like micro-partitioning, where the engine naturally organizes data into tiny, highly indexed blocks.
So when you query native Snowflake, the engine knows instantly which millions of rows it can completely ignore.
Yes, but when you force Snowflake to write to external Iceberg tables, you abandon those proprietary optimizations.
The engine loses its map. Instead of instantly zeroing in on the correct block of data, Snowflake has to scan vastly larger amounts of irrelevant data to find the answer.
And since Snowflake bills based on compute time, losing that micro-partitioning efficiency means queries take longer to run, which directly burns through your paid compute credits faster.
Oh man, so you were cutting your storage bill in half, but potentially skyrocketing your compute bill to compensate for the lost efficiency.
Which perfectly illustrates the trap of architecting based purely on infrastructure spreadsheets.
Because analyzing cloud costs solely by looking at the price of a gigabyte of storage ignores the daily reality of the engineers.
Exactly. The labor required to maintain this shared Iceberg environment is immense. Engineers have to manually manage file compaction, relentlessly monitor the cross-platform refresh schedules, build custom alerting mechanisms, and carefully negotiate every single schema change with the other department.
You end up spending all the budget you saved on the halved storage by paying highly skilled engineers to act as synchronized traffic cops for a shared folder.
It's exhausting for the teams.
And we at Kanerika see this play out in the field all the time. When we at Kanerika are analyzing these architectures with clients, we notice a very distinct pattern.
What kind of pattern?
Organizations that force the shared Iceberg approach purely to save a few dollars on storage almost always hit a critical boiling point right around 60 to 90 days post-go live.
That 60 to 90-day mark is a fascinating metric. What specifically triggers the friction at that point in the life cycle?
It's almost always the first major upstream system update. After a few months, a source system like an enterprise CRM or an ERP undergoes an upgrade, which forces a mandatory schema change in the downstream beta.
Right, that's inevitable.
Exactly. And if the organization is using Fabric mirroring, Team A updates their Snowflake tables, the CDC mechanism catches the new columns, and the change ripples through cleanly.
But in the shared Iceberg model?
In the shared Iceberg model, that schema change hits the shared ADLS container instantly. Both teams feel the impact simultaneously.
Chaos.
Total chaos. Suddenly, automated pipelines fracture, Power BI reports throw errors in front of the executive team, and you have two distinct engineering cultures pointing fingers at each other over a shared storage bucket. The hit to engineering morale is immediate and toxic.
Which is why the financial model for Iceberg really only aligns with reality when a dataset reaches truly massive, prohibitive volumes.
Like what kind of volume?
The industry consensus centers around the 50 terabyte threshold.
Wow, 50 terabytes.
Yeah. If a single table or dataset is below 50 terabytes, the fractional savings of avoiding a second storage copy absolutely do not justify the sustained engineering overhead and risk of maintaining the shared chain account.
But if an organization does hit that 50 terabyte mark and decides the Iceberg route is a financial necessity, or if they realize a previous architecture is failing and need to migrate, they face another massive hurdle.
The migration itself.
Right. Reverting or migrating these structures requires brutal manual DDL or data definition language rewrites. Engineers have to hand code new table structures, remap permissions, and carefully port historical data. It takes months of manual labor.
It's a massive undertaking.
And this is exactly where our teams deploy the FLIP accelerator. We at Kanerika engineered FLIP to automate and cut that exact complex migration effort by up to 75%.
That's a huge reduction.
Yeah, instead of a 6-month manual slog, we routinely deploy these tailored, robust architectures in just 2 to 8 weeks.
Accelerating the migration is critical, but securing the outcome is equally important. Regardless of whether an organization defaults to the isolation of mirroring or the shared storage of Iceberg, maintaining clear visibility is non-negotiable.
Which is why we integrate the entire process through Microsoft Purview.
Essential.
Absolutely. Because when executives are making multi-million-dollar business decisions based on a Power BI dashboard, you have to be able to trace that data lineage all the way back to the source. Without governed lineage, you haven't built a modern data platform. You have just constructed a very expensive, very fast data swamp.
Governance is the anchor. So, considering all of this, if you are architecting a data stack right now and weighing these two distinct paths, what should your default strategy be moving into 2026?
Based on the operational realities we've covered, the verdict for the vast majority of enterprise setups is clear. Establish Fabric mirroring as your default integration layer.
Make it the default.
Yes. It keeps the Snowflake engineers and the Fabric analysts beautifully decoupled and operating at their maximum native speeds. It preserves Snowflake's proprietary micro-partitioning optimizations, and it feeds the business dashboards seamlessly without a crippling coordination tax. It is objectively the lower friction path to value.
And you reserve the Iceberg external tables approach strictly for the behemoths. You apply it selectively to those massive 50 terabyte plus data sets where the pure economics of duplicating the data absolutely justify taking on the shared operational headache.
Exactly.
The crucial takeaway is that these two architectures are not mutually exclusive. They can and should coexist within the same enterprise environment based on the specific use case of the data.
It is about being strategic and outcome-driven rather than dogmatically clinging to a single architectural philosophy. And we at Kanerika are continuously partnering with organizations to tailor these specific architectural choices. By analyzing your unique workloads and team structures, we ensure your entire foundational stack is AI-ready and resilient, entirely bypassing the migration complexities that historically stall these massive modernization initiatives.
It is an incredibly dynamic time to be working in enterprise data. To close our analysis today, there is a broader underlying trend highlighted in the material that requires serious consideration.
Oh, I know what you're going to say.
We are watching open formats like Apache Iceberg and Delta Parquet rapidly narrow the performance gap with deeply proprietary closed systems. The entire industry is accelerating toward a standard where the physical data format is completely open and universally accessible.
Which fundamentally changes the power dynamic of enterprise software. For decades, database vendors locked you into their ecosystem by holding your data in a proprietary format. Now the format is open, and vendors have to compete purely on the speed and efficiency of their compute engines.
It raises a profound question for the future. As these open formats become the undeniable universal standard, will the very concept of a proprietary native database storage layer eventually become completely obsolete?
Wow.
What happens to the economics of the enterprise data landscape when the storage layer becomes permanently and entirely decoupled from the compute engine across the entire industry? It is a paradigm shift that is going to redefine how every major tech titan builds and monetizes their platforms over the next decade.
That is a phenomenal disruptive thought to leave on. The bridge we are meticulously engineering between platforms today might just serve as the foundation for a completely borderless, frictionless data ecosystem tomorrow. Thank you so much for joining us for this deep dive into the material and for listening to Kanerika's podcast, The Digital Shift. Keep analyzing your architectures, keep innovating your processes, and most importantly, keep questioning the defaults of your tech stack. We will catch you next time.